Hello everyone, I am Amal Rich, Assistant Professor, Department of Computer Science, St. Joseph's College of Arts and Science for Women, Hosur. In this video, we are going to learn about pointers in C++. When a variable is declared, the memory needed to store its value is assigned a specific location in memory that is called memory address. Generally, C++ programs do not actively decide the exact memory addresses where its variables are stored. Fortunately, that task is left to the environment where the program is run. However, it may be useful for a program to be able to obtain the address of a variable during runtime in order to access data cells that are at a certain position relative to it. Pointers. A pointer is a variable whose value is the address of another variable. Like any other variable or constant, you must declare a pointer before you are going to work with it. The general form of a pointer variable declaration is type asterisk variable name. Here, type is the pointer's base type, that is valid C++ data type, and variable name is the name of the pointer variable. The asterisk you used to declare a pointer is the same asterisk that you use for multiplication operation. The following are the valid pointer declaration. In pointer declaration, we can use all the primitive data types like int, double, float, character, and we can give the asterisk and give the pointer variable name. All the primitive data types are accepted in pointers. Address of operator. The address of a variable can be obtained by preceding the name of a variable with an ampersand sign, known as address of operator. For example, here we are going to store the address of the variable myvar to foo. That's why we are putting ampersand sign in front of the variable myvar. The following example clearly explains the use of address of operator. Here we are going to store the value 25 into the variable myvar, and we are going to store the address of myvar to the variable foo, and we are going to store the value of myvar to bar. This picture is representing the values and addresses how the operations are done in system. Here myvar value is equal to 25 and the address of myvar is equal to 1776. So foo value is 1776, bar value is 25. Dereference operator, that is asterisk. A variable which stores the address of another variable is called a pointer. An interesting property of pointers is that they can be used to access the variable they point to directly. This is done by preceding the pointer name with the dereference operator. The operator itself can be read as value pointed to by. This is the example for dereference operator. This statement can be read as bas equal to value pointed to by foo, and and the statement would actually assign the value 25 to bas, since foo is 1776 and the value pointed to by 1776 is 25, so bas contains the value 25. Here is an important note of the pointers. Ampersand is the address of operator and can be read simply by address of. Asterisk is the dereference operator and can be read as value pointed to by. This is the very important point in pointers. Pointer arithmetic. There are some arithmetic operations we can perform on a pointer because the pointer stores an address which is a numeric value. The arithmetic operators are increment operator plus plus, decrement operator minus minus, addition plus, subtraction minus. Increment operator. When you are using this increment operator, it increments a pointer, that is, the size of its type increments its address. For example, for incrementing an integer pointer whose address is 450, after increment it will be 454 because the size of int is 4 bytes. Decrement operator. When you decrement the pointer, its address will be decremented by the size of its type. Both increment and decrement operations on a pointer are done in array operations. On increment, the pointer will point to the next memory address of the next element. On decrement, it will point to the previous memory address. Addition. Addition operator is plus. When you perform an addition operation to the pointer ptr by 1, that is ptr plus 1, then it will point to the next memory address. Similarly, if you add 3 to ptr, then it will point to the address that is 3 times the size of the type of pointer. So if you want to move to the next memory address, we can use this addition operation. Otherwise, if we are using any other number means that number will be multiplied by size of the type. Subtraction operation, that is minus. When you subtract on a pointer, it will decrease the address by n asterisk size of type. Array name as pointers. An array name contains the address of the first element of the array, which acts like a constant pointer. It means the address stored in the array name cannot be changed. For example, if we have an array named VAL, then VAL and ampersand VAL of 0 can be interchangeable. For example, here we are using an function called arrpy, array pointer. In this function, we are going to declare an array with the size 3 and we are storing the value 5, 10 and 20 into the array VAL. Now we are going to declare a pointer variable, that is int asterisk ptr. Now we are going to assign the address of uh, first index to ptr. So this can be done like this: ptr is equal to val or ptr equal to ampersand val of 0, that is first index value. Then these two statements are same only. So we are using a output statement to print the pointer indexes 0, 1 and 2. In the main function, we are calling the function arrpoi. Now, and this is the output of the above program. The output is elements of the array are 5, 10 and 20. Here, this is the pictorial representation of the array name with array elements and also the pointer variables. Pointers and string literals. String literals are arrays of type character plus it is terminating by null character. Here is an example which is explaining how we are using pointers and strings together. In this example, we are using the string oops and then a pointer to its first element is assigned to ptr. Now we just imagine that oops is stored at the memory location that starts at address 1800. So this is the table how the oops is stored in the memory. So O is having the memory address 1800 and the next character is having 1801, the next one is 1802 and the last character is having 1803 and we are using the null character, so that is stored in 1804. As pointers and arrays behave in the same way in expressions, ptr can be used to access the characters of a string literal. In this example, character x is equal to asterisk ptr plus 3 and character y is equal to ptr of 3. Here both x and y contains the value s because ptr plus 3 pointer first value is 1800 plus 3 is 1803. So the value of this x is s, and ptr of 3, that is pointer with arrays. So array 0 is O, 1 is O, 2 is P, and the pointer value, that is array's third value, is S. So Y also contains the value S. Pointers to pointers. In C++, we can create a pointer to a pointer that in turn may point to data or another pointer. The syntax simply requires the unary operator asterisk for each level of indirection while declaring the pointer. Here, character variable is A and the pointer variable is B and pointer to pointer variable is C. So A is contains G, B is contains the address of A and C is contains the address of B. Here B points to a character that stores G and C points to the pointer B. Null pointers. A null pointer is a pointer that point nowhere and not just an invalid address. Following are the two methods to assign a pointer as null. Here int pointer 1 is equal to 0, or we can assign null value like this also. ptr is equal to null. Void pointers. Void pointers are pointers that point to a value that has no type. This means that void pointers have great flexibility, that it can point to any data type. This is a special type of pointer available in C++ which represents the absence of type. These type of pointers cannot be directly dereferenced. If you want to dereference means we have to first transform on into some other pointer type that points to a concrete data type before being dereferenced. Invalid pointers. A pointer should point to a valid address but not necessarily a valid element. These are all called invalid pointers. Uninitialized pointers are also invalid pointers. Here is an example. In this example, ptr1 is uninitialized, so it becomes an invalid pointer. And ptr2 is out of bounds of array arr, so it is also becomes an invalid pointer. Here we have to note one thing, that is invalid pointer do not necessarily raise compile errors. So, in conclusion, we can see the advantages of pointers. Pointers reduce the code and improve performance. They are used to retrieve strings, trees, arrays, structures, and functions. Pointers allow us to return multiple values from functions. In addition to this, pointers allow us to access a memory location in the computer's memory. Now it's time for a small assessment on the topic pointers in C++. Go through these MCQs and post your answers in the comments. Thank you all.